A very good morning to one and all. I'm A. Nagaraju. So today we're going to design a 30 dB directional coupler in KU band. So in ADS software. So let's start with the theoretical part in the front and then go to the design one. I won't take much of your time, so we'll go to the couple of slides. So where do we use this directional coupler? So generally we use this directional coupler whenever we have to couple some power for a testing as a pilot signal or a calibrated signal in the starting case. So we try to reduce the power of a signal by putting parallelly both parallel coupled microstrip lines in the same format, for example, like this. And you give input from the here and take output from here. So the power, incident power, which is transferred from here to here, so that is the coupled power which we say that we are trying to take it. So you can see there's one of the microstrip design, of a directional coupler. So there are a couple of difference of the couplers. You can see here there's a hybrid coupler here. There's one more branch line coupler, and this is the directional coupler. This is the directional coupler. This is directional coupler. So all the photos which I took from the Google. So it's just for the reference, you can see it. So what is the main important things which we have to see is for a directional coupler you have to understand what is the length you are going to figure out and what is the space between the main line and this coupled line, the spacing between these two. So I mean, if you talk it very precisely, the spacing between here and what is the length and what is the angle, what is the size you have. So these are the things which we have to figure it out. So now in the design part, so I have already have a design of a 30 dB directional coupler that way in the KU band. Let's take. So I'm trying to operate in KU band. So let's take 16 gigahertz as the center frequency and design this directional coupler. So in ADS software, it is very easy to design this directional coupler. So let's see how is it going to go it very fast. So the first thing is to design this directional coupler. First thing we have to do is open the ADS software. So I'm going to open the ADS software to finish off the workspace. So first I'll directly go to the layout design as name it as coupler. Okay. So now the first thing to do is I have to draw the outer line. So there's an outer line of 30 by 30 So I'll take it as the ground plane and select contour layer. Here if you can see contour layer, and I'll draw contour layer. So this will become my ground plane. So why did I select the contour layer? As I'll tell you, when I'm doing the microstrip topology, I'll assign contour layer as the ground plane. So then it would be easy to me also to understand. So if you are new to this ADS software, so these are the points where you can take the main lines. So okay, now just a sec. Okay, so now I have to draw the main lines. So for that, I have to again go to this. So from the center, there is 13.06 and 0.52. So again from here. So see if you can see 8.34 is the distance over here. So what we have to do is we have to draw this line 8.34. So how do I have to draw that line? So I can take anything. So this is one of my easiest way which I try to do it. So I'll just draw a box. Here's width is and one, so that is 8.34. So this is 8.34 line. So 8.34 plus uh, so I'll draw again. So I'll go to the con layer, select the rectangle and draw a rectangle over here and see what is the length of the line. So From here to 0.25. From here to here, it's 10.48. So 10.48, 10.48, and 0.52. That's what. So I have to change the height of the distance to this. So this is a move option. Click on the move option, click it here, and you will get it. Okay. Now, if you want to copy this, just click on this one. You can select the reference point and do Control R, where you can shift the same. So now I have to do in this format. So I'll just click OK. Now, if you can see, I have the right one. So the right one is 10.48. So the actual one is 13.06. So I'll just see 13.06. So now it's done. So now I have to take this one also. So I'll try to take this one, put it over here. So the upper side is done. So what is the best way for a ADS software is you can directly take the other and also select all these and copy from one single position and just try to press this button as a mirror over x-axis. As you can see, in 1 second I could do the replicate one. So this is as simple as that. So now I'll try to unite these all, selecting by first selecting all these, and now you can press Shift U for the unite one. So now it's united. Okay. So this is the basic steps of designing. Um, so I kept this two holes for the screws. So whether we can put it or not, we'll see in the future. But right now we'll start putting the ports and trying to simulate it. So, so I just kept bound layer so that it is not infinite boundary condition. So I'll just make it very simple. So now I'll change it to bound layer. Uh, Now the way for the main thing to do is assign the ports. So you have to assign ports in the proper sequential format. So the first port goes to here. So you have to see, you have to see, I'm getting the first port over here. I'm not sure why is it going under the one layer. So the first port over here, and the second port over here, third port over here, and fourth port over here. Okay, and now assign the ports. Now it's time to do the EM topology or EM setup. The first thing is to do the EM setup, create EM setup, and then if you want FEM to do the FEM analysis, the substrate you have to add the substrate. Click on the new substrate, substrate one. So I'll just change that this into 17 micron and intrude into the substrate. And this is I'll change it into 4350B or 5880. I'll change it into 4350B. I'm trying to do it in 4350B as earlier I told you. So that's 10 mil. So again the ground layer 17 micron. Okay. Now the ports are done. Okay. So that's it. I'll put the frequency plan 12 to 13 to 18 gigahertz. Let's take 18 gigahertz and then simulate it. I clicked on the simulation button. This is the EM simulation button. The EM simulation got started. So let's wait for some time. And once the EM simulations are done, I'll show you how we can plot the results and all the results, and we'll fill up the tabular column. And that's it. That's the easiest way to design a directional coupler. So once the simulations are done, so we'll get into the results. So you can see there's a plot. You'll automatically appear with the plots like this. But instead of that, I'll plot another one. You can select this tabular column, zoom in, and check this. I'll select 1, 1, 1, 2 for the insertion loss, 1, 3 for the isolation, 1, 4 for the coupling, 4, 4 for the coupling gradient loss, and 2, 2 for the return loss, and 3, 3 also. So it's our up to wish. Now select on OK. So click on marker, new line, take any frequency 16. Let's take 16. So S11 is 10.7, so it's 10 dB, and S22 is 10.7, S33 is 11, S44 is 11. Okay, greater than 10 dB, and S13 is 56. That means this is 13. The isolation is 56 dB, and the coupling is 54, 52 dB. So it's quite good. Good have, and the insertion loss is zero point 0.8. So let's fill up the tabular column. So S11 is minus 10, S22 is minus 10, S33 is minus 11, S33 is minus 11. This is my 0.8, and isolation is 52 dB, minus 52 dB, and coupling, sorry, isolation is 56, and coupling is 52. Okay, so these are the results. So if you want to have better isolation, you just need to have space. If you want better retinal loss, you need to have change with the length. And I did not give the proper excitation, I feel. So we have to keep it in the center, then you'll get the better retinal loss. So this is one of the method, and this is the simplest way to understand or learn the ADS software. Where is it? So I think this would be a starting introduction of the directional coupler. So stay tuned for the different RF design simulation project. Thank you guys. And if you have any doubts, you can get into my LinkedIn page, and you can ask me your questions over there or drop in an email. Thank you.